Video of 3D geometry. In this first video, we will just revise some logic of vectors which will be used in 3D also. What are those logic? First is you should know that from 2 points in 3D, three-dimensional geometry, A whose coordinates are x1, y1, z1 and B whose coordinates are x2, y2, z2, we can find out, you know how to find vector AB, right children? This we have already learned. x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now you should know that when we talk about the coefficients of I cap, j cap and k cap, they are known as direction ratios ABC. So I can say direction ratios are ABC and direction cosines are either cos of an angle which the vector forms with the x-axis, that is either L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma, or if direction ratios are given, we can also find L as plus minus A upon under root of A square plus B square plus C square. Similarly, M is plus minus B upon under root of A square plus B square plus C square. Similarly, N is plus minus under root of plus minus c upon under root of a square plus b square plus c square. Now again you can know the fact, if I take a that side, b that side and c also that side, I will get the same ratio in all three. So I can say that direction ratios and direction cosines are always proportional to each other. So I can say put it equal to lambda. This is also a known fact. This is also a known fact that direction, if I add square of the direction ratios and then I get 1. Why? Because in the numerator also children I will get a square plus b square plus c square. In denominator when I'll take the whole square, this root gets cancelled, again I will get a square plus b square plus c square. So that is why when I add the square of the direction cosines, I will get 1. So L square plus m square plus n square is equal to 1. And this is again a fact which we have already studied. When 2 points are collinear, their direction ratios are always proportional. Since they are parallel, collinear means parallel to the same line. Okay, so this is the basic knowledge which you should have while starting 3D geometry. Let's move on to the first exercise. The exercise is very simple. For the first question, since the angles are already given to you with the x-axis, y-axis and z-axis, so you should know that how to make direction cosines. So L is, for the first, L is cos 90, M is cos 135 and N is cos 45. So this is no problem. Cos 90 you already know. Cos 90 sin 0 जो होता है वही cos 90 होता है. So this is 0, right? Cos 135, can I write it as cos? If you want to write down, can I write 90 plus 45 children? 90 plus 45 means second quadrant. After school to college, 90 plus theta second quadrant में आता है. Right, this is till 90, this is 90 plus theta till 180, right? So second quadrant, and क्योंकि 90 है तो ये angle change जाएगा. That means the answer will be sin 45, and sine is positive, so that means this is negative. So you know what is the value of sin 45? That is minus root 2. Similarly, cos 45 you already know, that is 1 by root 2. So that is how we will find L, M and N. That is the direction cosines. Now question number 2, find the direction cosines of a line. Again you know this fact, which makes an equal angle with the coordinate axis. Equal angle means alpha, beta and gamma equal है. इसका मतलब obviously cos alpha, cos beta and cos gamma भी equal है. That means I can say L equals to M is equal to N. L, M, N equal, you know the relation. L square plus M square plus N square equals to 1. So can I say 3L square is equal to 1? So L is equal to plus minus 1 by root 3. Similarly, M is also the same thing and N is also the same thing. That is how we will solve question number 2. Let's move on to question number 3. Direction ratios, that means A, B or C की value given है minus 18, 12 and minus 4. You have to find direction cosines children. Again direct formula. L is plus minus A upon under root of A square plus B square plus C square. तो इसमें already a negative given है, so we will not consider both the signs, right children? So जो sign given है -18 का square plus 12 का square plus -4 का square. Similarly, m will also be 12 upon same denominator, and n will also be -4 upon the same denominator. That is how you will find question number 3. Now, question number 4 children. Show that the points are collinear. Again, collinearity का logic मैंने clearly आप लोगों को समझाया था that the direction ratios have to be proportional. You can find out. Suppose I take this as A, this as B, and this is as C. Let's find out direction ratios of AB. So direction ratios of AB, that is A1, B1, C1, formula आपको again आता है x2 minus x1, y2 minus y1, and z2 minus z1. So let's find out. X2 minus x1 means -1 minus 2, that is -3. Similarly, this one is -2 minus 3, that is -5, and this one is 1 minus 4, that is -3. This is direction ratios of AB. Similarly, let's find out of BC also. So A2, B2, C2, again I am applying the same formula. 5 minus of -1, that is 5 plus 1, this is 6. Then this is 8 plus 2, that is 10. And this one is 7 minus 1, that is 6. So check, are these proportional? Check please. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Just check, are we getting -3 by 6, -5 by 10, -3 by 6? Yes, we are getting them as equal. It is -1 by 2. So yes, since the direction ratios are proportional, so therefore we can say points are collinear. So this is the logic of collinearity. All right. Question number 5, again, direction cosines of the sides whose or sides of the triangle whose vertices are given. Again, children, very simple logic, ABC, just the way we did question number 5. Can we find direction ratios of AB first? Again, same A1, B1, C1, same formula. X2, the way we found out in question number 4. This is y2 minus y1 and this is z2 minus z1. And then you know L1 is a1 upon under root of a1 ka square plus b1 ka square plus c1 ka square. So that m1 is also b1 upon under root of a1 ka square plus b1 ka square plus c1 ka square, and n1 is also c1 upon under root of a1 ka square plus b1 ka square plus c1 ka square. Similarly, you can find it for BC also. Same formula for BC, A2, B2, C2, and similarly for CA, A3, B3, C3. That is how you will get the direction ratios and the direction cosines for a given for the given vertices. So that is all for the first exercise. The entire exercise was based just on simple logics that you should understand कि अगर point given है तो direction ratios कैसे find करने हैं, direction ratios given है तो direction cosines कैसे निकालने हैं, या अगर directly angles given है तो direction cosines कैसे निकालने हैं. And collinearity का logic again इस exercise में repeat हो रहा था. अगर किसी भी दो sides के direction ratios आपस में proportional आते हैं, the points are said to be collinear. So that is all for the first exercise of 3D geometry. Thank you. And if you still have any doubt related to these concepts, please mention in the comment below.